In this episode of mathematics lesson, we are going to take a look at a question from application of derivatives. And it is from Maths and Stats Commerce Stream Maharashtra board from the part 1 book, exercise 4.3, question number 3. Application of derivatives. So, I mean, it's an application of calculus in the real life and in the financial aspects where all calculus can be used. You can get a feel of how the concepts can be used. So the question is from exercise 4.3. A metal wire of 6.5 centimeter long is bent to form a rectangle. Find its dimension when its area is maximum. So I repeat the question. A metal wire of 36 centimeter long is bent to form a rectangle. Find its dimension when its area is maximum. So what is given to us? It is given that the length of metal wire is 36 centimeter. So that's the metal wire. Let's say we are using it. Now this has been bent into form a rectangle. So that's the rectangle which you can see. Obviously, if this is a rectangle, it would have a dimension, right? So it should have a length and a breadth. So let's assume the length of the rectangle is x centimeter and breadth of the rectangle is y centimeter. So that's depicted in the image. This is an important concept on which this entire question is banked. Perimeter of the rectangle which has been formed will be equal to the length of wire. And you need to realize, you see, just take a look. I mean, this wire has been bent to make a rectangle out here. This rectangle cannot be bigger than the length of the wire. And when we say this rectangle perimeter cannot be bigger than the length of the wire, it basically means perimeter of rectangle is equal to length of metal wire. You need to recollect what's the perimeter of rectangle. So perimeter of rectangle, the formula is 2 times length plus 2 times breadth, which is 2x plus 2y, which is equal to 36. So we can see that this entire equation can be divided by 2. So dividing both sides by 2, we get 2x by 2 plus 2y by 2 is equal to 36 by 2, which is fundamentally x plus y is equal to 18. So we convert y and as the subject, and we get y is equal to 18 minus x. Let's give this as an equation number 1. Now we know that area of rectangle is length into breadth. That's the formula. Again, you have learned it in the past in class 10th. So recollect that. Area of rectangle is length into breadth. Basically, it means it is x into y. We will replace y with 18 minus x from equation number 1. So it is x into 18 minus x. Now let's convert this into a function because this is a function of x now. So we will convert this area of rectangle as a function of x. So it is fx is equal to area of rectangle is equal to x into 18 minus x. Now, what is this question? This question is asking us to find the maximum area of a rectangle which can be formed using this wire, which was of the length 36 centimeter. So basically, we have to, it's a maxima problem. We have to find the area for where we have a maximum area for a particular value of x. So take a look at the solution, which is given in the next page, next slides. So we have to find the value of x for which fx is maximum. So fx is equal to x into 18 minus x. Let's open the bracket, and when we open the bracket, what we get is 18x minus x square. Simple distributive property. Differentiating both the sides with respect to x, we get f dash x is equal to 18 minus 2x. Now, again, let's do the double differentiation. We get f double dash x is equal to minus 2. Now, do you realize f double dash x is equal to minus 2 means it is basically less than 0. This basically also tells me that for the function has a maxima for the value of x, which we are going to find out now. How do we get the value of x? We equate the f dash x to 0 to get the extreme values. So equating f dash x to 0, what we get, f dash x is equal to 0. So 18 minus 2x is equal to 0, and which basically gives us 2x is equal to 18 and x is equal to 9. Now when we have got x is equal to 9, do you realize that if, the length is 9? What is going to be our f double dash 9? For this value of x, what is the value of f double dash 9? It doesn't change. It remains same, negative, which is minus 2, which also tells us that for x equal to 9, we have a f double dash 9 is smaller than 0, which also tells us that the area is maximum when x is equal to 9 centimeter, and y is equal to 18 minus 9 which is equal to 9 centimeter. And where have we got it from? We have got it from equation number 1. Equation 1 is just reproduced here for you to again recollect. Y is equal to 18 minus x. We got it in the equation number 1. in that we have put in the value of x is equal to 9 and the value of y has come in 9. Now there is something remarkable which you are seeing. X is 9 and y also is 9 centimeter. What does it mean? This dimension of rectangle is 9 cross 9 centimeter. Now what is it, a rectangle? No. Now we know that because L and B are both same, length and breadth are same, so it's a square. And the dimension of the squares are 9 by 9. Thank you very much for watching the video.